Okay, this histogram, well, as soon as I see the word histogram, I'm automatically thinking that area equals the frequency. And to work out the area of a bar, I always do the height times the width, and that will equal my frequency. Okay, so the first one here, how high is it? 7. How wide is it? 1. That's why the frequency is 7. To work out 1 to 3, how high is it? It's 6.5. How wide is it? It's 2. So that frequency will be 13. And between 3 is less than or equal to the time, which is less than 5. How high is that? That's 2.5. It's 2 wide, so that'll be 5. And the last one, 5, is less than or equal to the time, which is less than 10. That is 3 high. And how wide is it? It's 5 wide, so that equals 15. So I've completed the frequency distribution. Okay, I could have just added up the squares. Hence, that means from here, calculate an estimate of the mean. The mean, don't forget, is the total divided by how many. So in this case here, I need to add up 7 between 0 and 1, but I can't add up 7 between 0 and 1s. I have to then look at the midpoint. And the reason it's an estimate is because I'm guessing that every one of those 7 will be roughly 0.5. And they will come to, I want my fx column, that will come to 3.5. The frequency is f times the value x will give us that. We got 13, well, on average 2, because the midpoint between 1 and 3 is 2. 13 2s, they come to 26. I've got 5 were on average 4, so that would be 20. And the midpoint of the last one between 5 and 10 is 7.5. I've got 15 7.5s, that's 112.5. If I add all those up, I get 162. And I have to divide it by how many families were together. And it says there are 40 families. Really, the best way to check that, add up the frequency, 15, 20, 30, 40 frequency. So the mean is 162, which is a total, divide by how many there were, 40, do it on a calculator, and I get 4.05. Just have a quick check to see if it makes sense. 4.05, we're just about here, in the middle of the distribution. That's great, that's done.